I'm not a scientist, but I have a feeling that when atoms are energized, that is how they behave under the microscope.
Hello, welcome to Solution Prime TV, and today we dive into mathematics. I'm going to talk about angles. Angles, we have applications of angles, so many applications of angles in our everyday life. This video is going to be in two sections. First video for the application of angles, and the second one will be a classroom work if you want to know calculations of angles. If you don't understand how angles are being calculated, how calculations of angles, anything like triangles, angles in a triangles, and angle in a straight line, two co-interior angles. We talk about angles in a parallel lines. We are going to talk a lot. We are going to do calculation on that. Basically, we are going to do calculations on that. So let me dive into applications of angles. What is angles? Angles are formed when two lines meet or when two rays meet, then angles are formed. For example, if I pick my hand, you see there's an angle formed here. That is the angle. One line, another line, when they formed or when they meet at this point. So there's an angle. So anytime I pick something like this, okay, let me pick this and that. So if I do this, there's an angle formed here. That is it. Angles formed here. This is the angle formed. Yes. So when two lines meet, there's an angle. So one line, another line, they meet at a point. So this becomes an angle. We know your angle. No, me say two. No, one line, another line, they meet at a point. So this becomes an angle. In our hairline is also it also forms an angle here. There's an angle here. Yes, that is, you see, applications of angles in our everyday life. We apply angles, but we don't know. For example, when you are walking, you also apply angles because your two legs, in between your two legs, there's an angle formed. Don't think what you are thinking. Stop thinking what you are thinking. Not that. But our focus is on angles. Your two legs, in between your two legs, there's angle formed there. Okay, over here is another angle. So we also use these angles in so many ways in geometry. When they want to project nuclear weapons like atomic bomb, nuclear bomb to other country, to attack other country, they also apply angles because they have to measure the angle in such a way that when the bomb takes off, when the nuclear bomb takes off, it will be able to meet or hit where they want to, or the location they want the bomb to, fall there. Yes, that is the application of angles. And also plane, when the plane is taking off, first of all, it will move, the movement will be on the ground to a point that it will fly, it will take off the ground. When it takes off the ground, it makes some angle with the ground, and that is angle. You see, if you picture a square, if you picture anything that is in a square form, there's an angle formed. There's an angle formed, and the angle in between every square is 90 degrees. So I made mention of degree. The degree is the unit of angles. Degree is the unit of angle. So in my previous, I have done videos on base quantity and derived quantity, unit and SI unit. There's a difference between unit and SI unit. In one of my videos, you can go and look for it and watch to know the SI unit and unit. Okay, so yeah, the unit, the degree tells us that we are measuring the thing in angles. Yes, anytime you see degree, then we are talking about angles. Anytime you see degree Celsius, then we are talking about temperature. So degree, the unit there tells something. Degree Celsius tells you that you are measuring temperature, but degree tells you that you are measuring angles. You see, let me consider, let's pick the clock, the wall clock, for example. You see, the wall clock also move in an angle. So you see, the clock makes an angle once it is moving around. You see, angle is everywhere. Angle is everywhere. Working in angle, Even when you are opening your mouth, you open it in an angle form. So this is angle. Angle is very nice. We dive into the calculation aspect of the angles, and we'll do more. Wait for the second part, which is full of calculation. If you're a student, if you're a JHS student, if you're a SHS student, you are a university student, you can watch this video when it comes to calculation aspect and know more of angles. It's going to be long video, but it's good for you to watch it so that you get more insight. Okay, so we are going to do the calculation part of the angles, and that is the plane geometry 1. Plane geometry 1 talks about angles. For the plane geometry 2, that is the circuit theorem. Yes, for JHS, they will not treat plane geometry 2 is SHS. For plane geometry 1, JHS, they will teach you, and SHS the same thing. So whether you are JHS student or SHS student, this is for you. Plane geometry 1, anything concerning about angles, we talk about it. So before we start, I'll talk about plane geometry small. What about plane geometry, or what is plane geometry, which is the angles? It refers to calculating angles or application of angles in a plane figures. That is plane geometry. Let's write something down. Okay, so that is plane geometry. Deals with the study of angles in a plane figure. Yes. So what are the plane figures that we have? Examples of the plane figures, we have square. Square is a plane figure, a figure with 2 dimensions. So square, it has 2 dimensions. Let me draw it well. So this is a square, length times length, 1 dimension, another dimension. We have rectangle, which is length times width, 1 dimension, another dimension. That is it. We also have rhombus, which is in a square form. It's a bent square, bent square. And we also have parallelogram, which is a bent rectangle, Oh, no, it's not nice. Yes, with arrows moving parallel to each other. Yes, and many more. Any figure with 2 dimensions is a plane figure. Okay, so that is it. So we chip into angles. What are angles? And we said that angles are from when 2 lines meet. So when you have 1 line, another line, then angle is formed. So here is the angle. This is how angle is formed. So over here, angle is formed here, angle is formed here, angle is formed here, because 2 lines meet here, another 2 lines here. The same applies to this side. And over here, this one here is 90 degrees, 90 degrees, 90 degrees. Over here to 90 degrees. The 90 here is also 90, here is also 90, here is also 90. That is the property of square, property of rectangle, and rhombus has its property. When you consider this, the angle formed here is the same as angle formed here outside. That is one of the properties of parallelogram. So they have properties. We'll dive into the angles and move forward. And we are saying that angles are formed when two lines meet. So one line, another line. Let me name here to be O, A, and B. So we are going to, learn how to name angle. How do we name this angle? Okay. So naming of angles. Assuming we have one line, another line, meet at this point O, and this is our angle. I have A, I have C. So this is line OC and line OA. You can represent it like this: OC or OC is also accepted, or OC dash, that is the same thing. Line OC or distance OC, OC, or this, you mean the same thing. And we have OA. How do you name this angle? So assuming this angle is X, how do you name this angle? Always when you are naming the angle, the middle letter is very important. I want to name this angle, so I can name this angle as angle using the symbol. That is it. The symbol here represents the angle. So angle COA, COA, and is the same thing as angle AOC, angle AOC, angle AOC is the same thing. Always where the point is located should be in the middle. So O is in the middle here, O is also in the middle here. So it's the same thing. Angle COA is the same as angle AOC. That is that. This is how we name angles. Let me give another example. So this is A, and here let me name it T, F, W. And this is angle Y degrees. Here, let me do it small w degrees. How do you name this angle? Okay, so in order to name this angle, you are going to apply the same concept here. Angle, you bring your angle symbol like this. Angle W, you are naming this Y angle Y. So it's going to be like this. So I'm going to get angle WT, TF. That is it. Angle WTF. It's the same as starting from here, the same thing. Just make sure that where the point is will be the middle. So angle FTW. That is how we name angle. You can feel free to pause the video and try the angle small w. Okay, so this angle is going to be angle WTA, which is equal to, is the same thing. It's the same thing as angle ATW. That is it. Yes. People confuses how to name angles. They find it difficult in naming angles. And this is how we name angles. Naming of angles, easy. We move to how to measure angles. How to measure angles. How to measure angles. Angles. How to measure angles. So assuming you've been given this angle OAD, and they are telling you to measure this angle. They are telling you to measure this angle. How do you measure this angle? We use instrument called protractor. So the protractor is used to measure angle. So what it means that the instrument for measuring angle is protractor. Instrument for measuring angle is protractor. That is it. So we have our protractor here. We are going to measure this angle. Because this is not drawn to scale because of this line. The line is not straight. So I'm going to clean it and draw a correct straight line. OAD. Two lines are formed. Let me do corrections here. The dot here, the circle here is the unit of angle. So angle is measured in degree. Angle is measured in degree. That is it. So if I have 50 like this, then I'm talking about angles. It means you've measured the angle of that particular figure. 180 degrees. So the degrees here is telling you that this is the unit of angle, as I said it earlier in the video. Okay, so how do you measure it? Make sure you place your protractor at the point the two lines meet. So this is my protractor. I'll place it. Then make sure I adjust it to fall on this line. Okay. Yes. So I'm reading from here. When you are reading from here, the zero starts from here. It's inside. So 0, 10, 20, 30, 40. And over here, we have one small, there's a small lines on there. You can remove your protractor from your macet and follow me. So we have 1 degrees, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 degrees. The same applies to, so if you want to measure your angles, I have 0 here, 10, 20, 30, 40. So 40 is not up to 50. So I will count it. Every one line is 1 degree. So I have 40 here, 40, 41, 42, 43, 44, 45. Yes, so the angle is 45 degrees. This is how we measure angle. Okay. So this is how we measure the angle. It depends. When you have something like this, you can choose to, when you are trying to measure it from this, unless you are measuring this side. If you are measuring this side, you can measure from this to that. So this is my point: 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So over here is 150. So this angle is 150 degrees. If I want to measure from this side, the same thing, let it be on the point and adjust your protractor for this side to be on the same line. Okay, so 0, 10, it is indicated there, 0, 10, 20, 30. So this is 30, but from 30, 1 degree is added to 30. So it's going to be 31. 31 degree. This is how we measure angle. Okay, so we are moving to the calculation aspect. You've gotten the concept of naming of angles and how to measure angles. We are moving on to the next, which is types of angles. Types of angles. This video is a full video, and anything about angles, you get it. Types of angles. We have acute angles. Acute angle. Okay, so these are the types of angles. We have acute angles, obtuse angles, reflex angles, a right angle, complementary angle, supplementary angle. Okay, let's move on. So for acute angle is any angle which is greater than 0 degree but less than 90 degrees. So any angle after calculations, when you find any angle which is less than 90 degrees, which is less than 90 degrees but greater than 0 degrees, then it is an acute angle. So example, 30 degree is an acute angle because it falls between 0 and 90. It's less than 90 degrees. We have obtuse. Example, any obtuse angle, any angle which is greater than 90 degrees but less than 180 is obtuse angle. So 91 degree is an obtuse angle. 179 is also an obtuse angle. Reflex angle, any angle which is between 180 degrees and 360 is a reflex angle. Example, 190 degrees, etc. Because 190 degrees falls between 180 degrees and 360 is a reflex angle. Then 4, a right angle. A right angle is any angle which is 90 degrees or with a magnitude of 90. For example, and it is being represented by this. Anytime we see, this is a perpendicular line. Anytime we see a perpendicular line, two lines perpendicular, then they form an angle of 90. It's a right angle. So over here is a straight line, another straight line meeting at this point perpendicularly. Then here is 90 degrees. So we use this symbol to represent 90 degrees. Anytime you see something like this symbol here indicates that the angle is 90 degrees without showing that it is 90 degrees. That is perpendicular. So over here to 90 degrees. So 90 plus 90 will give you 180 degrees, which is angle on a straight line. We'll talk about it. Okay. Then the fifth one, complementary angles. What are complementary angles? Complementary angles is two angles that sum up to 90. That is complementary angle. Take note, two angles that sum up to 90 degrees is complementary. So if you have three angles, A plus B plus C, and it's equal to 90 degrees, it is not complementary angle. It is not complementary angle because for complementary angle, there are only two angles, like A plus B should give you 90 degrees, which is 30 degrees plus 60 degrees is equal to 90 degrees, which is correct. It's a complementary angle. Supplementary angle, two angles that sum up to form 180 degrees, then it's supplementary angle. For example, A plus B supposed to give you 180 degrees. So if it is 3, 4, 5, 3, 2 and above, 3 and above to give you 180 degrees, then it is not supplementary. Every supplementary is only two angles summing up to form 180, then it's supplementary. To any two angles summing to form 90 degrees, then it's complementary angle. So these are the types of angle, and most of the calculation we are going to do, when we calculate for the angle, it will fall within these types of angle. When we solve after the calculation, getting the answer, and your answer falls within this, it is an acute. Within this, it's an obtuse. Within this, reflex, right angle, complementary, supplementary. That is. So we are going to solve more questions. We are going to solve questions under complementary and supplementary. Then we dive to the rest. Before we continue the complementary and supplementary, let's talk about the special properties of an angles. Some special properties of an angles. Let's talk about it. Okay. So That is, we say angle on a straight line. So angle on a straight line. This is a straight line. Question two. Question two, we have angle around a point. Okay, let me clean this one. Let me use only this. Okay, so some special properties, we need to talk about it. Okay, so angle on a straight line sum up to 180. Angle on a straight line sum up to 180 degrees. So what it's trying to say is that anytime you see angles on a straight line, then when you add them, you are going to get 180 degrees. For example, this one, we have a plus b plus c plus d is equal to 180 degrees. But for supplementary, if only two angles sum up to 180, then it is supplementary angles. But when it is two or more and sum up to 180, then it becomes angle on a straight line. So two angles summing up to 180 can also be an angle on a straight line, because once it is on a straight line and it is making angle of 180, it's also 180 degrees. Okay, so this one too is angle on a straight line. X degrees plus y degrees plus z degrees is equal to 180 degrees. So over here, I can choose to indicate my degree angle, telling you that the angle inside, the C degree inside is an angle. The C there is an angle. Okay, so angle around a point, anytime you see angle around a point, when you sum all the angle, it will be equal to 360 degrees. 360 degrees. 360 degrees. So this one, we are going to have a plus b plus c plus d plus e plus f equals 360. So a plus b plus c plus d plus f plus e is equal to 360 degrees. This one, we are going to have w plus r plus z plus a is also equal to 360. That is the special properties. Angle on a straight line sum up to 180. So angles on a straight line sum up to 180, no matter how the angle is. If assuming I have another straight line like this, and this is t, I can also say that this angle is angle on a straight line. So I can say b degrees plus c degrees plus d degrees plus what, t degrees is equal to 180 degrees, because this line is a straight line and the angles are on it. So it will also give you 180 degrees. And if I have w here, then angle around the point. This is the point, and the angles they are around that particular point. The same thing here, the same. So this one will sum up to 360. So A plus B plus C plus D plus T plus W will give you 360 degrees. We have another property that I want to talk about it. This is to another one, which is 3 vertically opposite angle, vertically opposite angles, opposite angles are equal, are equal. Vertically opposite angles are equal. What it's trying to say is that, for example, this angle A, B, let me name this angle T and W. This is vertically opposite. The angle is vertically opposite to this. So it is equal. What it means is that angle A degrees is the same as B degrees, and W is also vertically opposite to this. So W degree is also equal to T degree. So what it means that if A is 50 degree, then B is also 50 degree. Yes, because A is equal to B and is equal to 50 degree. That is the property. They are vertically opposite. This angle is opposite to this, vertically opposite to this. So W is the same as T. This is this vertically opposite to this. So this is that. That is the property of vertically opposite angles. Okay, that is the property of vertically opposite angles. So we are going to solve more questions. I'm just giving you the clear understanding of those properties, and we try and solve more questions applying the complementary angles, because it's talking about summation. We are adding them, we are adding them. So we are going to solve questions on that. Okay, so let's solve this set of questions based on what you've learned so far. Okay, let me add another one to it so that for Okay, so these are the questions we are going to try our hands on it and tackle based on what we've learned so far. Okay. The first one, what property are you going to apply? When you consider this diagram, I can use angle around a point to solve the problem. This and that, this is a point and the angle is around it. The angle is around it. So angle around a point. Question one, I'm going to have 40 degrees plus 70 degrees plus y is equal to 360 degrees. Angle around a point. Around a point. Yes, angle around a point. Around a point, I'm going to have 40 degrees plus 70, which is 110. 110 degrees plus y is equal to 360 degrees. We are going to make y the subject. So our y is equal to 360 degrees minus 110 degrees, which is equal to 250 degrees. So this means that this angle here is 250 degrees. That is a cool answer. Let's go to the second one. For the second one, considering this, you know that it is angle on a straight line. So 2, angle on a straight line. 30 degrees, that's the property. Angle on a straight line. This is a straight line. So the angles are on it. So we are going to have 30 degrees plus 50 degrees plus x and is equal to 180. Angle on a straight line. On a straight line. Okay, so we are going to 30 plus 50, which is 80 degrees plus x is equal to 180 degrees. X is equal to 180 degrees minus 80. So you are going to have 100 degrees. So this means that this angle is 100 degrees using the property which says that angle on a straight line. Okay, we are moving on to the question number 3. When you consider this, I told you earlier that whenever you see this box is telling you that the angle there is 90. So I have A and I have 40 here, and the total is 90. That is the one we said complementary angles. Two angles, when you sum up two angles and it's equal to 90, then it is supplementary angle. So this implies that our A plus 40 degrees is equal to 90 degrees. That's the property that we discussed earlier. So A is equal to 90 degrees minus 40 degrees. So 90 minus 40, we are going to have 50 degrees. So here, the angle here is 50 degrees. That is it. Very cool question. We are moving to the question number 4. Question number 4. Question number 4. I have x. This is straight line, and so I can apply two properties. I can say 150 degree plus x degree is equal to 180, which is angle on a straight line to solve it. So my x is going to be 180 degree minus 150 degree, which is equal to 30 degree. That is, I used angle on a straight line. Angle on a straight line. I can also use supplementary angles. two angles are said to be supplementary if when you sum up is equal to 180. So there are two angles. So 150 plus x is equal to 180 degrees. The same concept. Our x is equal to 180 degrees minus 150 what degrees. So x is equal to um, 30 30 degrees. So that is that. So we have our x to be 30 degrees. So it's accepted. Once we are indicating x here, it's telling that we don't have to bring the degree. So once you bring the degree, or x is equal to 30 degrees, it's the same thing. But most of the times, you just, after that, you ignore the, that is it. The angle there is x. So once you find x, x is 30 degrees. So if I indicate x here, it tells you without degree x, it's telling you it's 30 degrees. But if I'm bringing the degree, if I'm bringing the degree, then straightforward, my x will be 30. X will be 30, but already because x degree, so 30, if I put 30 here, it will be 30 degree. So that is it. It's accepted. If you are not indicating degree over there, if you indicate the degree, then this is what you are going to arrive at. Yes, that is cool questions. Another set of questions. Another set of questions. Okay, another set of questions. Okay, so another question, but here we are going to use the we are going to name the angles using the letters. Yes, because for the first question, for the first set of questions, we didn't introduce letters, but the second group of questions we are going to introduce letters so that we can also work out with the angles using the letters so that we'll be familiar with it. We'll be able to know. So we have A, let's say here is B, C, D, W, R. And this is the diagram. Over here, there is a square, something like this. I told you earlier that whenever you see something like this, it means the angle from there is 90 degrees. It's 90 degrees. So this means that from here to here is 90. You can zoom it for you to see it clearly. Okay. So find x and I find x and y, and I find x plus 2y. That is the question. I find x, value of x and y. I find the value of x plus 2y. Okay, let's solve this problem. First of all, we know that this this angle is 90. So if here is 90, this is angle on a straight line. So automatically, here too is going to be 90. Here it's also going to be 90. So this side is going to be 90, other side is going to be 90. Since this is a straight line, and this line from this point W to C, this line is perpendicular because of this. because of the symbol here, which indicate that it is 90. So automatically here will also be 90, so that angle on a straight line will sum up to 180. Okay, so we can choose to find y. In the diagram we're given this, but based on that we can know that this is also 90. Okay, so the other side, you can write straightforward, y plus 30 degrees is equal to 90 degrees. That is it. So since we want to name the angles, we want to practice how to name the angle very well, so we have to use the letters. So y is angle WCR, angle WCR. Okay, so angle WCR plus angle RCW. This is the angle like this, and it's 30 degrees. Yes, 30 degrees. So it's here is CBR. So RCB or BCR is the same thing. So the WCR is the same as RCW, is the same thing. So the angle here is 30. So angle what? RCB, which is equal to 90 degrees based on the symbol indicated here. Okay. So angle WCR is what? Y. Y plus angle RCB is 30 degrees is equal to 90 degrees. So our Y is equal to 90 degrees minus 30 degrees. So straightforward, our Y is equal to 60 degrees. That is it. So the value of Y is 60. Okay, since we are done, we can also calculate for the X. We are using the same property. You can start from here, but since we want to know how we can name the angles, some of the questions you have to apply this before solving it. Yes, so you need to understand. Yes, you need to understand. This one, since here is 90, I've told you that the other side is also 90 because they fall on angle on a straight line. If here is 90, the rest will also be 90. Okay, so that one to angle ACD, that is 2x. Angle DCA or ACD. So angle ACD plus angle, we want to name this x. So angle DCW or WCD. So let me pick DCW, which is also equal to 90 degrees. Okay, so you are going to have 2x plus, because angle ACD is 2x, angle DCW is x, so plus x is equal to 90 degrees. So 2x plus x will give you 3x. That is mathematically 2x plus x will give you 3x equals 90 degrees. Over here, you divide both side by 3, and our x is going to be yes, 30 degrees. Yes, so we have 30 degrees. Y is 60 and x is 30. Okay, let me clean this part. After we find for the value of x, this one, after getting your y, in the diagram, they indicated this symbol, which is 90. So from this, you can also use another method, or you can apply angle on a straight line, since only this side is 90. So if this is 90, we know that the other side is 90. Or you can choose we can choose to write 2x plus y plus 30 angle on a straight line. So 2x plus x plus y plus 30 is equal to 180 degrees. Angle on a straight line. Angle on a straight line. Okay. So over here, this and that, I can say is a what? Complementary. Complementary angle. Yes. Where two angles sum up to 90 is complementary. Okay. So over here we have 2x plus x, which is 3x, plus we know that our y, we've calculated for our y, and y is 60. 60 degrees plus 30 degrees is equal to 180 degrees. So we are going to have 3x is equal to 180. 60 plus 30 will give you 90. So when, okay, let me do it so that you understand more. 60 plus 30 is 90 degrees equals 180 degrees. So we have 3x plus, 3x is equal to, the reason why we are moving this one to the other side is that we want grouping of like terms. We want those with x one side, those without x one side. So those with x, I have 3x here. 90 will cross the equal to sign because this does not contain any x. So it has to move minus 90 degrees. So 3x is equal to 180 minus 90 is 90. Divide both side by, both side by 3, both side by 3. Our x is equal to 30 degrees. It's the same thing. Or you can choose to, over here, you can also choose to write, or this side, you can also choose to write 2x plus x plus 90 degrees equals 180 degrees angle on a straight line, because y plus 30 will still give you 90, like what I've written here. Because in the diagram here is straightforward 90, so it's better to use this than writing everything, because the y, you went to find it. So if y is wrong, you get everything wrong. So it is advisable to use this one, so that from here 2x plus x, you are going to get 3x plus 90 equals 180. So you are there. It's advisable to use this rather than that, rather than this, because the y, you went to find out, to find for the value of y. So if the value of y is wrong, everything will be wrong. Okay, we move to our question. We are done with I. Therefore, the value of x is 30 degrees and y is 60 degrees. And yes, x plus 2y. So you are going to have x is 30, 30 plus 2 times y. 30 plus 2 times y. Our y is what? 60 degrees. 60 degrees. So 60 degrees. So we have our 30 degrees plus 2 times 6, which is 12. Then you add your 0. So 2 times 60 will give you 120. So we have 120 degrees. So 120 degrees plus 30 degrees, straightforward, 150 degrees. So this is the final answer. So from this, we are moving to another properties in a parallel lines. When two lines, or when a line is parallel to each other, two lines parallel to each other, and we have a straight line passing through these two parallel lines. How do we solve the angles in it? So we are going to solve that one too. Okay. So properties of angles in the parallel lines. So what is a parallel line? A parallel line is a line, or let's say two lines, a parallel lines, they are lines that do not meet. Let me use that one. A parallel lines are lines. What are parallel lines? So parallel lines are lines that do not meet. For example, if I pick these two lines and I indicate parallel line like this, then it means this line, they are not going to meet till infinity. So they will continue moving till thy kingdom come. Yes, it means they are not going to end. There's no way they are going to end. But if I do something like this and that these are not parallel lines, I can't say they are parallel lines because they will move and they will reach a point, they will meet, because you see the way the bar is moving and this one is moving straight. So probably they will meet at a particular time. They will meet at a particular point, unless I unless I do this, then it means they will move. They are not going to meet. So every parallel lines do not meet. So a line with an arrow, two lines, this a line with an arrow, a line with an arrow, that's a ray. This is also a ray. A line moving together, which they do not meet. Then parallel lines. Okay. So we are going to solve questions under it. We are going to prove all the properties under parallel lines. Okay. So sorry for my line. This is not drawn to scale, so take it like that. Okay. So arrow like this, and I'm saying these two lines are parallel. A, B, C, D. These two lines are parallel. Then it means they are not going to meet. So I have two parallel lines and a straight line passing through these two lines. Yes, and basically this is what we see in the textbooks. Yes, you can also have something like this. You can also have something like this. Two, another three lines. Yes, three lines. Three lines parallel to each other. You can also have four lines, but we are just using this one to explain. It's the same thing here. Yes, the same property that we are going to apply here. So just pay attention and you are free to go. Okay, so over here, assuming we have our A, B, C, D, E, F, G, H. Assuming, let me use this one too. A, B, C, D. Now let me change the letters. X, Y, Z, R, W, V, M, X. Let me change it. N, O, P. Something like this. Okay. So what are the properties over here? Whenever you see a parallel lines, whenever you see a parallel lines like this, there's a rule. The angle from here, you need to do some specific calculations in order to get your answer. In order to get your answer. In order to get your answer. Yes. So obey this one. We've been doing it several times, but this one is 3. I can also introduce another one, which is 4. It's the same concept, just that you need to follow whatever that we are going to discuss. Okay. So the properties that we will see here, we've discussed one of the properties. So the properties here, one is vertically opposite. The 2 is corresponding angle. corresponding angle 3 alternate angle alternating vertically opposite alternate angles. Fourth one. Okay, so these are the properties that we're going to use. By another one, we can also apply angle on a straight line here. Angle on a straight line. Then another one, two co-interior angle is equal to co-interior angle. I will explain. Most of the times, some other books use it differently. When we reach here, I will explain over here. I'll explain it for you to understand. Okay, so 1, 2, 3. We've done this one, vertically opposite angle. Vertically opposite angles are equal. So when they are vertically opposite, they are equal. Corresponding angles are also equal. Alternate angles are also equal. Then angles on the straight line, we've done it already. Angle on the straight line, every angles on the straight line sum up to 180. So we know that one. But two co-interior angles is equal to 180. I will explain it here. When we go to triangle 2, we are going to explain it. When you look into different textbooks, they have different meaning to that. So no problem. Okay. Yes. So over here, two co-interior angles will be equal to 180. I will explain it here. Okay. So let's move to vertically opposite angles. That is one. The vertically opposite angles. We've done vertically opposite angle already. So over here, we know that I'm considering this one. Over here, I know that A is equal to D because A is vertically opposite to. Then I have B is equal to C. It's also vertically opposite. That is it. This line and this line. This is vertically opposite to this, and this is also vertically opposite to this. This is also vertically opposite to H, and F is vertically opposite to G. It's the same thing. So A is equal to D. We said vertically opposite angles are equal, so A is equal to D. Over there, B is also equal to C. E is equal to H, comma, F is equal to G. That is it. For the first one, that is vertically opposite angles we are talking about. Okay, let me write vertically opposite. Vertically opposite. For the first one, the second one to the same thing. Second one, which one are vertically opposite? I didn't introduce another one. Let me introduce this one as beta and this one as alpha here. Alpha, this symbol, alpha and beta are signs symbols. Yes, they are sign symbols. So I'm using it here. And JHS worldwide, that is what we'll be using. Alpha, beta, we have a lot. We have mu, they are all symbols in mathematics and science. Okay, so the second one, you know that X is vertically opposite to R, Y is vertically opposite to Z, W is vertically opposite to beta, V is vertically opposite to alpha, M is vertically opposite to P, and N is vertically opposite to O. So it's the same thing here. I did the first one. Second one, you know, so you can try your hands. X is equal to R, comma, y is equal to z, comma, w is equal to beta, comma, v is equal to alpha, comma, then we have m is equal to p, comma, n is equal to o. So you are going to apply the same concept here to solve the problem. That is the property. Let's move to uh, 2, corresponding. Let's move to corresponding. So 1, corresponding angles are also equal. So corresponding angles are equal. The same thing, vertically opposite angles are equal. So corresponding, those who are correspond to two angles which are corresponding. Okay, if you consider this, you see this is the line, and this line divides these two lines into two parts. So when I'm considering the aspect, E is on top of the line CD, and A is also on top of the line AB. So those on top of CD is E and F. AB is what? A and B. Okay. So if you consider this, you see F, those on top, B is at this side of the line, F to the same thing. So E is on top and is at the left side. So E is corresponding to this place, and B is corresponding to this. Yes. So B are equal. So this means that A is equal to what? E. A is on top of this line and is here. This one too is on top of this line and is also here. So E correspond to A and B correspond to F. So B is also equal to F, comma. Then we check the down ones. The C here will correspond to this and the D here correspond to that. So this means that C is equal to G, comma, and D is also equal to H, corresponding angle. They are all equal. So this and that are equal. A and E are equal. B and F are equal. C and G are equal. And D and H are equal. So if A is 10, E is also 10. That is it. It's the same thing here. If you consider this over here, if I'm considering the second one, since these are parallel lines and this is on top of that, this is also on top of that, this is also on top of that, then it means corresponding angle X is those on top. This is on top of this, the angles on top of line NQ, M, O, T, W, that is it. W and V, X, Y, M, N. So for the first one, we've done it. So this corresponds to that, and this also corresponds to that. And for the second one, we are going to have X is equal to W is equal to M. Yes, most of the textbook, they've been using two parallel lines to explain. You can choose to even introduce another parallel lines to this. We have 3 parallel lines. If it is for the same procedure, the same concept here, we are applying the same concept here. So X is equal to W is equal to M, corresponding. This side to the same thing, I have W to be equal to V to be equal to N. So Y is equal to V is equal to N. That is it. Then the down one, R will be equal to beta will be equal to P. and z will be equal to alpha is equal to O. What it means is that when z is 10, alpha is 10, O is also 10. When r is 20, beta is 30, p is, where r is 30, beta is 30, and p is also 30. The same applies to the top one. Okay, you've gotten the concept. We are moving to alternate angle. Alternate angle. Alternate angle. Alternate angles. So alternate angles are also equal. I said it earlier. Alternate angles are also equal. Okay, so if I consider this diagram, for the first one, alternate is like this. So angle form here is equal to the angle form here. It's like S. This one will help you to understand. This symbol I'm using will help you to understand. It's like S. So this and that angle is corresponding. This and that is like S. So they are corresponding. So this angle corresponds to the angle here, to the angle here. So this means that what D is equal to E, comma, and this one also alternate to this. This one also alternate to this. So this implies that C is also equal to F. Yes, that is alternate angle. It's like S. So they are always inside. This alternate to that and this alternate to that. This one to the same thing. If I want to consider these two, if I want to consider this and that, I know that our R will alternate to W and Z will alternate to V. Z will alternate to V. If I'm considering these two, if I'm considering these two parallel lines, I know that my R will alternate to W. So alternate angles are equal. Alternate angles are equal, comma, and we have Z alternating to V. So Z is equal to V because they are equal. That is the first one, considering these two parallel lines. If I want to consider these two parallel lines, MO and NQ, then beta will alternate to, beta will be equal to alpha, and beta will be equal to M, and alpha will be equal to beta. That is it. If I'm considering this line and that, then this one will be alternate to this, and this one will be alternate to this. I just want you to understand it properly. I just want you to understand it very well. That is why I've introduced three parallel lines. Always it is two. But you need to think deep. So this alternate to that. I'm considering the parallel lines NQ and TW. So this will alternate to that. So R will be equal to M and Z will be equal to N. Yes, that is cool. Very clear. Okay, so we are going to solve more questions. Okay, that is that. Okay, let me go to the angle on a straight line. Angle on a straight line. Fourth one, angle on a straight line. X plus Y, they are angle on a straight line. The down one to fourth angle on a straight line. Let me consider the first one. You see, A and B are on a straight line. So A plus B is equal to 180 degrees. Angle on a straight line. Angle on a straight line. Sum up to 180. So if I consider this, A plus B is equal to 180 because they are on a straight line. If I consider the down one too, the down one also fall under straight line. C plus D is also equal to 180 degrees, angle on a straight line. Yes, this one, the second parallel line, is also on a straight line. That is E plus F is also equal to 180 degrees. If I consider this line too, this line is also a straight line. So those who fall on this, so C plus A is also equal to 180 degrees. And this one too is on a straight line. So D plus B is also equal to 180 degrees. The same applies to this side. This side to the same thing. G plus E is equal to 180. F plus H is also equal to 180. This on a straight line, E plus F. The same applies to this side. X plus Y, angle on a straight line. Z plus X, angle on a straight line. Y plus R, angle on a straight line. Angle on a straight line. Angle on a straight line. So that is the concept. That is that. Okay, the last one, which is co-interior angles. Two co-interior angles. Two co-interior angles. Two co-interior angles. Okay. Two co-interior angles. Please pay attention very carefully. Kindly pay attention so that you understand this. Yes, how whatever you call it. Okay. So those co-interior angles is equal to two co-interior angles is equal to 180 under parallel lines. So this and that are co-interior angles, two co-interior angles. This angle. So if you add D plus F, it will give you 180. That is D plus F is equal to 180. The property. And when you do that, you are going to get the answer correctly. D plus F. And the other side will be this and that. So C plus E is equal to 180 degrees. 180 degrees. The same applies to this. R plus B. R plus V is equal to 180 degrees. And this one, Z plus W is equal to 180 degrees. Beta plus N is equal to 180 degrees. That's the property. And alpha plus M is also equal to 180 degrees. You've gotten the concept. Alpha plus M is equal to 180 degrees. And if I'm considering this line and this line, then M plus Z will be equal to 180 and N plus R will be equal to 180. So that is that. For the first one, since you've gotten the concept, I shouldn't, write it, but whatever. Let me write it down. Then D plus F is equal to 180 degrees. The second one, Z plus W is equal to 180 degrees. R plus V is equal to 180 degrees. We also have alpha plus M is equal to 180 degrees, comma, then beta plus N is equal to 180 degrees. Then the one that I said, R and N, R plus N is equal to 180 degrees, and Z plus M, Z plus M is equal to 180 degrees. Let me check whether. So Z plus M, that is that. So that is the concept over here. So we are going to solve more questions under it so that you get more. We are finishing everything under plane geometry 1 angles. Yes, you are killing everything. So that when you watch the video till the end, you are done with angles. Any questions and angles, you can be able to solve it. After this, we are moving to properties of angles in a triangle. It is very important. Properties of angles in a triangle. So keep watching and exercise patience. If you are tired, get a short break, enjoy, and continue. So questions. This is 70 degrees. This is x. We have y. Okay. Um. Okay. First question. Easy. Let me use this one. Easy question. So 30 degrees. I have my m. I have y. Okay. So for the first one, you are find x, and this one find m and y. Value of m and y and value of x. Okay. So you are going to apply the property that we just did. Okay. For the first question, here is the x. How are you going to solve x? Okay. Considering this, you can see that this is a straight line and this is a parallel line. Another property corresponding, you can apply corresponding here, because when you check this line, this x is above this parallel lines. 70 is also above this parallel line. So they are above, x is above, 70 is above. They are also here. If I consider this line, they are here. So it is corresponding. X is correspond to 70. So question number one, straightforward. X is equal to 70 degrees. You are done. That is the shortcut or the short form of finding x. Someone can also apply another method to get an answer, or you can also use another method. You draw a new diagram and indicate a letter here. So let's say I have this, and this is a long period, a long process. This is a long process. Okay, so I can name this to be T, and already here is 70 degrees, and I have here to be X. Okay, so I can say that this angle is vertically opposite to T. So I can write T is equal to 70 degrees. T is 70 degrees. What property? Vertically opposite. Vertically opposite angles are equal. Are equal. Are equal. That is it. So this is a vertically opposite to this. So after getting this, right now, I know my T is 70 degrees. And I can apply another property, alternating angle. This is alternate to this. So I can write T is equal to X. T is equal to X into bracket. Alternate angles are equal. Alternate angles are equal. So therefore, we know that T is 70. So 70 degrees is equal to X. So therefore, X is equal to 70 degrees. The same thing. But you see, this is very short. This is very long. Unless you introduce another T for examiner in case of exams, as writing your final exams, which is BEC or SS or any outside exams that you are writing in terms of one's math exams. You need to introduce your t in the diagram for the examiner to know that you've introduced t. If you introduce t here in the question paper given, then you are not examiner don't know where the t is, where the t come from. Yes, so you have to draw another diagram, introduce t. So this one, the faster your brain, the faster you're able to know the shortest distance or the shorter way of solving the problem. So this is easy. In real life, people will be thinking deeper, thinking about something that they are not able to solve it. But when someone comes in within a short period of time, is able to solve it. That's it. Okay, so we are moving to the second question. This one, to the same thing, I can apply another method. I can also indicate W here, assuming this is my W. You see, this is a long process. W, in new one, you indicate W here, or you can indicate W here. When you indicate W here, then you can see angle on a straight line. So W plus 70 is equal to 180. You see, W plus 70 equals 180, and 70 will cause the equal to sign to subtract 180. So you're going to get W to be 110 degrees. 110 degrees. When you are done, then you can write W plus X is equal to 180. Property, co-interior angle. Like W plus X is equal to 180. 180 degrees. After getting 180 degrees, you know that W is 110. So 110 degrees plus X is equal to 180 degrees. So X is equal to 180 degrees minus 10 degrees, and it's what? 70 degrees. You see how beautiful math is. So you can switch it in anyhow, obeying the property. What you have to do is to understand the property. You have to keep the property in your mind. Property in your mind. If you're able to keep the property, everything is easy. Just watch it. You apply the method. Pa, pa, pa. You see, this question is easy. The short way is x is equal to 70 degrees. What property is that? Corresponding angles are equal. Angles are equal. You see? So I'm just trying to solve all the problems in the property so that we get it good. Some questions are difficult to extend that you're not going to use only one property like S is equal to 70 degrees corresponding angles. That be, you have to apply 2 or 3. Like this one, I've done 2 properties. Others to 3, others to 4. It depends on how you are going to solve the problem. Okay, let's try the second one. Second one, you can use different method to arrive at the same answer. If someone does that, you see different kinds of answers, but different kinds of method or procedure, but we are all going to arrive at the same answer. Question number 2, we are asked to find M. If you watch M carefully, you will see the straightforward angle on a straight line. Bah! This is a straight line, so it's fall under it. So angle on a straight line, bah, 30 degrees plus M is equal to 180 degrees. Angle on a straight line sum up to on a straight line. Bah, 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 bah. So straightforward, our M is equal to 180 degrees minus 30 degrees, and you're going to get 150 degrees. Quick, we are done. And you got to M. How for the Y, just observe it very carefully. Y, I can draw another diagram. So this one, you need to draw a diagram above. So my diagram is supposed to be here before this question, because you have to go through the question. If you don't introduce the diagram, you can also write it here. You can introduce it like this, and this is M, and this is 30 degrees. This is Y. You want the examiner to know what you are doing. Yes, you can't introduce any variable and all of a sudden the variable is equal to that. Examiner will not understand. Okay, so I can use alternate angle here. So I can introduce another letter which is T, then I will use alternate angle to find this. That is fantastic. That is fantastic. So I can say M plus, from the diagram, M plus T So this is a new diagram. If you don't indicate new diagram, they will know that you've introduced t. M plus t is sorry, it's not m plus t. It's m is equal to t. What property? Alternate angle. Yes, you have to introduce because you are using the property. Anyhow you use the property, make sure it is in the right way. So this is equal to that. Yes, I've introduced another variable. So therefore, I know that my m is 150 degrees. So therefore, t is equal to 150 degrees. Perfect. So this is t. Once I've gotten t, I can use angle on a straight line. I can use t plus what? Y is equal to 180 degrees. Angle on a straight line. On a straight line, sum up to 180. Pa! So t is 150 degrees plus y is equal to 180 degrees. So 150 is this, y, I'll have my y here, 180. Grouping of like terms, y must stand alone, the other one will cause 180 degrees. This is 150, when it crosses, it's going to be negative 140 degrees. So this one cause you are going to get 30 degrees. Wow. So this means that m and y are equal. M and y, they are equal, but look at the problem. You will not know unless you apply the property, and you can't just stand up and tell us that m is equal to no. Only this that the answer is the same, but generally there's no property which says that this is equal to that. No. Okay, this one too, once I've introduced another variable here using the alternate angles and angle on a straight line, I can also choose to also introduce maybe t here. I can also introduce t here. You see, math is so nice to extend that if you understand the concept, since I understand the concept, I'm able to solve it using the property anyhow. Okay, so I can also introduce t here, and I can say m plus t is also equal to 180. What property? Co-interior angle. Two co-interior angles is equal to 180. So m plus t is equal to 180 degrees. So we know that our t is 150. So t is equal to, let's say we have 150 degrees plus t is equal to 180 degrees. So t is equal to 180 degrees. This one will cause the equal to 0. You can minus 150 degrees, and it's equal to 30 degrees. Wow. So since I'm able to get t to be over here, the first one, the t was here. So the t, when t is here, we had 150. Yes, we had 150. But assuming someone introduced t here, so you see, you are going to do it like this, and you are going to get 30. Once you get 30 degrees, this is vertically opposite. You see, properties, Charlie. So t is equal to y. And we know that t is 30, so 30 is equal to y. So y is equal to 30 degrees. Perfect. Cool. You see? Okay. Let's solve another question. Let me write another question then. Let me see whether I can write a very deep questions. One tough question then. We are done with it. Okay. Okay, let me write it here. So find x. We asked to find x. That is cool question. Okay. So how do you solve this question? Find the value of x. Ha. This is a tough question. We have two parallel lines. You see, the first diagram, I drew three parallel lines. That is it. 1, 2, 3. Then a line. We are going to apply the same concept because there's no way this is a parallel line is moving. See, if I extend it, something like this. This is something like this, right? They are moving. But here is the case. Since this is a parallel line, I can't say this is equal to that tabi. The property is like this. When a line is here, there must be another line to, help you solve this problem. So whenever you see questions like this, you have to introduce another parallel line. That is why for the third one, I was saying that the second diagram, 3 lines, I said I can introduce another one. So you are going to introduce, let me label it. Let's say we're given that A is equal to, this is B, C, D, R. Yes, if this is R, then extending this, I can say, let me write C. I just want us to use the angles, latest angle, to use the angle itself, not like the one that we did that we introduced here and other stuff. We can also do this, introduce your letters X. Okay, let's go. Let's try it. You know that here is R. This point is R. So let me introduce another parallel lines. And here is R. I can say this is N W. Yes, I've introduced another parallel lines. The parallel lines I've introduced is just helping me to solve the problem. Without this, you can't solve the problem. So we have some problem, you have to introduce, and these are the questions they mostly bring, the tough questions. You saw smaller questions, small questions, and small, moving to the bigger questions. So these are tough questions. So know how I'm going to solve it. Since this is a parallel lines, and this is a parallel lines, okay, this bigger angle is 64. So take note, is this angle which is 64. But if you want to know this angle, I can use alternate angle. That is this line, this cut this line like this. You get it? So this is like this. So here is 25 degrees. Here is B, and the point here is R. But over here, we are solving for this. That is it. Yes, because we have another line which goes like this, and the bigger one is from here to here is the 60, and we have our X here. Okay, so this is what we are doing. So follow and get the concept. So this is alternate to this. So over here, I'm going to have 25 degrees. 25 degrees. But you see, I'm just demonstrating it in the diagram for you to know. But in the calculation, you have to write it in a nice way so that examiner will understand. Okay. So you draw the question. There was no letters, so you have to draw the diagram again, indicate your letters, then you show everything so that the examiner will know that the angle A, B, C, and the angle that you are talking about is in the question. Okay, so this will alternate to that, and we know that this and all the total here is 64. So if here is 25 degrees, this one will be 64 minus 25 degrees, and which is equal to 39 degrees, which is equal to 39 degrees, it's not 39, yes, 39 degrees. You see, so here is 39, here is 25. That is a very nice question. You see how I'm deducing the problem. So once I'm able to get 30, if here is 30, here is 30, this is a parallel line, and this there's a line there's a line here. So I can also see that this alternate to this. Yes, it's like this. So we have this point. We know that this is 39 degree and this is x. So I can say this is alternate to this. So this means that we use two properties to solve this problem, unlike the one that we used only one property. So this is how you are going to go about it, and see how you are going to label your angles very well for the examiner to know. It is difficult when you are labeling the you are using the angle format. So open your naming the angle is very important. So take note of that. So this is your new diagram written. So angle ABR. This is it. Angle ABR is like this. So here is the 25. So ABR. You can see RBA. I've told you in the video. So take note of that. So angle ABR is equal to this angle. Yes, it's equal to the same angle here. Angle BRW. That is it. This angle. Not the bigger angle, this angle. Yes. So that is angle BR, angle B point, another point here. W. Yes. What property is that? Is alternate angle. Alternate angles are equal. Alternate angles are equal. Okay, so I can straight write, therefore angle BRW is equal to 25 degrees. So right now, here was 25. We've gotten here to be 25. This angle to be 25. So in the diagram, we are not showing anything, just that you have to observe it and know what you will do about it. But we are asked to find x. The reason why we are doing all these things that we are asked to find x. And before you find x, you have to move from one step to another till you get x. You can't jump over this thing to get x. There's no way. Unless you move it, you move it a little bit by bit to get the answer. Okay, so since here is 25, we've gotten that this is 25 degrees. But the bigger one, here and here, like what I said, here and here is equal to 64. So I can say this angle here, we've calculated for it. It is angle BRW plus this angle, and which is angle WRC or CRW. Okay, is equal to what? 64. You see how I'm solving the question? 64. So this plus that is equal to 64. But we know that this is 25. So it's 25 degrees plus angle WRC is equal to 64 degrees. So angle WRC, we are making angle WRC the subject, which is equal to 64 degrees. This one will cause the equal to sign. Grouping of lights and 25 degrees. We are going to have 64 degrees plus minus 25 degree, which is 39. Yes. So you've gotten this one to be 39. Wow. Okay. Then another property, angle WRC. This is the angle, right? Then we've gotten this angle CRW. So angle WRC or CRW is also equal to this angle angle RCD. This is the angle. yes, is equal to angle RCW. Know how to name the angles. It's very important. Right, we know that this angle is x. So once you don't write it like this, you can also write angle this is equal to x, because in the diagram we're given x already. So without naming the angle, you can choose to write x. And we know that angle WRC is 39. So what property is that? Alternate angle. Alternate angles are equal. Angles are equal. Okay, so we have angle WRC, we have 39 degrees is equal to x. So therefore, x is equal to 39 degrees. Perfect. You find for x. That is a cool question. Yes. We will try questions on that, but before that, I want us to discuss angles in a triangle. When we are done, we'll solve questions together with this. These are the tough questions. And angles in a triangle too. There is a property we need to know. After done with that, we solve more questions to that. Okay. Oh, sorry. Since let me start from here. But before we talk about properties of angles in a triangle, we need to discuss some properties of triangles. You get it? You have to. The general properties of triangle. For every triangle that you know, all it has three sides, three sides. It has three sides. It has three angles. So the reason why the three sides tells you triangle, three. Yes. Okay. And it has the angles in it. The total is equal to 180. So every triangle, when you sum up the three angles, let's say one angle A, another angle B, another angle C. So A plus B plus C will give you 180 degrees. So anytime you sum up an angle in a triangle, you have to get 180. So let's go to types of triangle. We have one, equilateral triangle. Equilateral triangle. Equilateral triangle. So the properties of equilateral triangle, all sides are equal. One. Let me state the properties. When I'm done, I will explain it for you to understand. All sides are equal. All sides are equal. Two, all angles are equal. And they are equal to 60 degrees. So each angle in an equilateral triangle is 60. So three angles. So here will be 60 degrees, here 60 degrees, here to 60 degrees. And 60 plus 60 is 180. and 60 plus 60 is 120. 120 plus 60, 180. So that obeys the property of the triangle, the general property of triangle, which says that three angles, when you add any three angles in a triangle, you have to get 180 degrees. Okay. So for equilateral triangle, this side is the same as this side, is the same as this side. That is why I've represented by this. So anytime you see diagram like this with this, then it tells you that all the sizes are equal. Or if, yeah, it tells you that this, it means that all sizes are equal. Okay, that is equilateral triangle. For equilateral triangle, sizes are equal and angles are also equal, and each angle is 60 degree. Okay, so we are moving on to the second one. The second one, which is scalene triangle. You have to know the properties of the types of triangles so that in case of any questions, you'll be able to, solve it. Okay, so scalene. All sides are not equal. All sides are not equal. All angles are not equal. So whenever you see something like this, then it's telling you that the sizes are not equal. This is 1, this is 2, this is 3. So it indicates that the sizes are not equal. And the angles, if the angles are not equal, you can also represent it like this, and like this. Okay, so if you do that, it is also telling you the angles are not equal. Most of the time you don't use that. Yeah. Okay, so that is scalene. Let me talk something bit about the equilateral. For equilateral triangle, if I draw a diagonal line like this, it will divide this triangle into two equal parts, this and that. Also, this is going to divide it into two equal parts, and this side too is going to divide it into two equal parts. So that is that. This one is not going to divide it into two equal parts. This side too, no. This side, no. Okay, let's move to the 3, which is isosceles triangle. Isosceles triangle. Okay, so you can check it out, the spellings. I think that is it. For isosceles triangle, two sides are equal. But the other side are not equal. So if here is x, automatically here will also be x, because this line falling on this straight line is the same thing. These two lines falls on this straight line, so probably the angle this one will make will be the same thing. It's like you have these two markers, they are equal. If they are equal, if I draw a straight line direct, the angle from here will be the same as angle. If I do it like this, it's the same angle formed. So any style that you adjust it with here fixed, with the top one fixed, you are going to get the same angle formed. Yes, that is the property of isosceles triangle. So most of the times you use this to represent it, and you can do this telling you that this side are equal and this side is not equal to the other side. That is it. So if here is 50 degree, here will be 50 degree for isosceles triangle. So two sides are equal. That is the property. Two sides are equal. Then the second one, two angles are equal. Two angles are equal. So that is the property. These are the properties of isosceles triangle. So we are going to use it. We will need it. We will need it in terms of calculations. We need it. That is why I'm writing it. Let's go to the fourth one, which is triangle. The fourth one, which is right angle triangle. Right angle triangle. So for every right angle triangle, one of its interior angle is equal to 90. So I told you earlier that whenever you see something like this, it is 90. So any triangle in which one of its angle is 90 degrees, then it is right angle triangle. Okay, so that is that. We have property, one of its angle is 90 degrees. We don't know the rest. Once one of its angle is equal to 90, then it is right angle triangle. Okay, so that is that. So that is the properties of right angle triangle. So these are the types of triangle and their properties. Okay, so we are going to talk about the properties of angles in a triangle, the general properties of angles in a triangle. Okay, let me start from this side, and let me clean this side. So we are going to talk about the properties of angles in a triangle. What I've written is the general property of triangle, the general properties of triangle, and general properties of each of the types of triangle. But we are moving on to properties of angles in a triangle. All these things are part, but we are going to talk about it too whenever you see triangle. Okay, so when you see triangle like this, and I have A, B, and this is C, and I have external one which is X outside. Okay, then I have this is Y here. Okay, and I have something. I have Z. Take note of that. We are saying that angle in a triangle sum up to 180. So over here, we know that our A plus B plus C will be equal to 180 degrees. Another property is here. Co-interior angle, two interior angle which are opposite, co-interior angle of in a triangle is equal to one exterior angle. So the opposite one. Okay, so listen. Two angles opposite to exterior angle. Two angles in a triangle is equal to its opposite exterior angle. Two angles in a triangle, the sum of two angles in a triangle is equal to opposite its exterior angle. So from this, B and C, this line where the angles are formed is opposite to the outside exterior angle, which is Z. So this implies that B plus C is equal to this Z. That is it. The same thing. These two angles, they fall on this line. They fall on this line. So it's equal to that exterior angle Y. So A plus C is equal to Y. What else? If I consider this line too, I have two angles here, A and B. So this one, addition, sum of it is equal to the outside angle or the exterior angle. So A plus B is equal to X. That is the property I'm talking about. So we are going to use all this property I've written to solve questions. So we are going to start now. Okay, that is that. And you see, let me prompt you. For isosceles triangle, I can do something like this. Then I can indicate this. If I indicate this, then it means this angle is the same as this angle because of the line they are joining, like I did earlier. This is that. This and that are equal. So if they are equal, the one that they will fall, they will make the same angle. So here is this. This is the line. Follow on this line. These two lines are falling and they are the same. So here will be equal to this side. Yes. And that is that. Okay. Let's try these questions. Okay, let me write these two questions and let's start with these two questions. Okay. How are you going to solve this question? This question is easy. Okay. So question number one. Question number one. We have this triangle and we are asked to solve for X and B. Already from this, B is equal to 70 degrees. That is isosceles triangle. Isosceles triangle. Okay. Isosceles, that is isosceles triangle. Because of this, since this side is equal to this side, this arrow is telling us that this side is equal to this side. Straightforward, B is equal to 70 degrees. How do you find for X? We can solve X by adding all the angles in a triangle. So we are going to have X plus 70 degrees plus B is equal to 180 degrees because angle in a triangle sum up to 180. So I have my X here plus 70 plus, we know that 70 is the same as B. So this angle here is the same as B, and we find for B. B is 70, so I have my 70 is equal to 180 degrees. So X plus 70, which is 140 degrees is equal to 180 degrees. Okay, so x is equal to 180 degrees minus 140 degrees. So our x is equal to 40 degrees. Yes, so that is the final answer for the value of x. That is easy. Let's move to question number 2. Question number 2. Question number 2. For question number 2, we are asked to find y. We are asked to find y. So finding y, you can draw the diagram again because this one is easy. We have b and x, so it was easy. We are not going to indicate any angles. But over here, you see, before we can solve this, we have to introduce numbers here so that we can find y. So this one, you have to indicate it. You can draw a new diagram. Yes, and represent this 30 degrees. That these two lines is telling that these sides are equal. This and that are equal. So you can represent it with letters A, B, C, D, and solve it using the angle, naming of angle form, or using or you name the angle and find for the y. Or you can choose to, in your diagram, you can choose to write maybe x here, x here, and you solve it. You can choose to write x. Okay, let's solve the 2. If I'm choosing this, then I can say angle DA line. Let me use line AD. You can use it like this, or you can choose to write it AD. Straightforward, no problem. So let me use this. Line AD is equal to DB. In the diagram, this is what they said. So you don't have to indicate it. What you have to indicate is that the angle. You can say let's angle what? DAB. This angle because A is the middle. I've explained how I've taught you how to name angle in the previous video. How to name angle is inside. I discussed that. So angle DAB is the same as angle ABD. Angle ABD. That is it, angle ABD. This angle is the same as this angle because this line is the same as this line. Yes. So X. Do you get it? You are naming this angle is the same as this angle. So we are letting this angle, which is equal to this, to be X. If this is so, then okay, I didn't indicate my Y. Then I can say that X plus angle DAB plus this angle angle ABD plus this angle 30 degrees is equal to 180. Angle in a triangle. Before you solve y, you can't just solve for y. Before you solve for I, you have to find for two values of here. When you get that, you can find angle on a straight line to get your y, or you can use that property I said, 2 interior angle is equal to the 1 exterior angle, the opposite exterior angle. Yes. So we know that DA is X. Markers are not good. So we have X, this one too is X plus 30 degrees is equal to 180 degrees. So X plus X is 2X plus equal to, this one we call the equal to sign, you can minus what? 30 degrees. So we have 2x is equal to 180 minus 30, which is 150 degrees. We divide both side by 2, both side by 2. Our x is equal to 75 degree. Yes. So after getting your 75 degree, right now you know that our x is 75 degrees, and over here to x is 75 degrees. After getting it, then we can find for y. I can use angle on a straight line to find for this. So angle on a straight line, let me use angle on a straight line. So I'm going to get x plus y is equal to 180 degrees. So x is 75 degrees plus y is equal to 180 degrees. So y is equal to 180 degrees minus 75 degrees, which is equal to 105 degrees. Yes, 105. Or after getting your x, you can also use another procedure here. You can use angle on a straight line, or 2 interior angle is equal to the opposite exterior angle. So this implies that here x, but over here this one was angle on a straight line here. So I can say angle ADAB is the same as x. So I can write my x plus 30 is equal to the outside angle, which is y. So I know that my x is 75. So 75 plus 30 is equal to y. 30 degrees. So 75 degrees plus 30 degrees is going to be the same thing, which is 105 degrees, which is equal to y. So therefore, y is equal to 105 degrees. It's the same thing. You see how beautiful math is. So the one that you choose, you are going to arrive at the same answer. Just that you have to know the properties. So the first one, question number 1, you see. So we are going to solve another group of questions, so that you get more insight and understanding. Okay. Let's solve this question. Okay, so for the first one, for the first one, um, 40 degrees is here. Okay, so for the first one, the same thing, the one that we did, the same thing. We don't know this, but based on that, we know that this line is equal to this line. So you can feel free and pause it and solve it. Okay, so angle x, y, z, this angle is the same as this angle because this line are the same. It's equal to angle x, z, y. You can x, z, y. You can represent it by any letter, which is y. So I'm representing it with y. Okay, so this implies that angle xyz plus angle xzy, this is this angle plus this angle plus the 40 plus the 40 degrees is equal to 180 degrees angle on a straight line. Angle in a triangle sum up to 180. So I have y plus 40 degrees is equal to 180 degrees. So over here, I'm going to have 2y plus 40 degrees is equal to 180 degrees. So 2y is equal to 180 degrees minus 40 degrees. So 2y is equal to, when you subtract 40 from 180, we are going to get 140 degrees. You divide both side by 2, our y is equal to 70 degrees. When you are done, you follow the same procedure. You can use 2 interior angle is equal to the one exterior opposite exterior angle. It's not any exterior angle, the opposite one. So if this line, this and that, this angle from here is equal to the one exterior angle, or after getting here, so right now this is the same as this, so we have 70 degrees here to 70 degrees. So it depends. You can apply angle in a straight line to find for your x, or you can use 2 interior angles equal to the opposite exterior angle. So 40 plus 70 is equal to 13x minus 20 degrees. So this and that, 110 degrees is equal to 13x minus 20 degrees. This one crosses the equal to sign to become 110 degrees plus 20 degrees is equal to 13x. So it's not compulsory. It's not always compulsory that x must start from, or x must come here, and those without numbers should come to this place. No, if this one crosses the equal to zero, you're going to get negative. So it's not compulsory that always x must come here. The way that you can solve it in order to escape negative or to be okay with it is what you have to do so that you get your answer safely. So I don't want problems, so I can remove the negative sign to this side so that I will get a positive number attached to x to be positive. So this and that, I'll get 130 degrees is equal to 13x. We divide both side by 13, both side by 13, and we have our x. We are dividing both side by negative. We are dividing both side by 13. Why are we dividing both side by 13? Like the one that I did. This one I divided by 2. This one too, I'm dividing by 13. The reason is that we want y. They are telling us to find y, but the value attached to y is 2. That is why I'm dividing by 2. So you can't just divide by any number like 5, 20. No, because the number attached to y is 2. That is why we divide by 2. This one too, the number attached to x, because we want to find x, and the number attached to x is 13. So we have to divide by 13 so that that 13 attached to x will move away, and we are going to get x, the letter that we want. So this one we are going to have 10. So 10 is equal to x. If 10 is equal to x, therefore x is also equal to 10. That is it. So it's not compulsory that you have to start the value of x here, then those numbers other side. No. So that is easy. You can also choose to solve it using angle on a straight line. So if you don't want this method, you can use 70 degrees plus 13x minus 20 degrees is equal to 180. You are going to get the same thing. 13x, this one will cross the equal to sign to become, we have 180 degrees there. So this one will cross the equal to sign to become minus 70 degrees. Then this one is negative. When it crosses the equal to sign, negative crosses the equal to sign to become positive. So positive 20. Here it was negative. When you cross the equal to sign, your sign will change. Here it is positive. When you crosses, the sign will change. So the sign will change to negative. This one will change to positive. So we have 13x is equal to 180 minus 70, 110 plus 20, 130. We divide both sides by 13, both sides by 13. Our x is equal to 10 degree. That is it. Easy. Sometimes too, from this, they can also ask you to find for 13x minus 20 degrees. So this one, straightforward. I have 13 into bracket. My x is what? My x is 10. We had the value of x to be 10. 10 minus 20. So 30 plus 10 minus 20. So 13 times 10. Sorry, 13 times 10 is 130 degree minus 20 degree, which is equal to 110. So generally, basically, this angle here is 110. Okay, that is a cool question. The second one is only one property. The second one is only one property. So only one property. Question 2, easy. Angle and triangle. So you can write P plus 30 degrees plus 3P plus 2P is equal to 180 degrees. Angle in a triangle. Angle in a triangle sum up to 180. So P plus grouping of like terms. I have P plus 3P plus 2P is equal to 180 degrees. P plus, so I'm grouping the like terms, those with P one side, those without P one side. So this is with no P, so it will cause the equal to sign to come minus 30 degrees. Why? Because it is positive here. When it crosses, it's going to be negative. So P plus 2P, addition of P's. We have 1P here, we have 3P here, we have another 2P here. So when you add them, 1P plus 3P, 4P plus another 2P, you are going to get 6P is equal to 180 degree minus 30 is 150 degree. Yes, 30. You divide both sides by 6, both sides by 6. Our P is equal to, so you just write your final answer there, then you are done. We are going to solve another set of questions, so that because solving of more questions helps you to understand the concept very well. So we are going to solve another question, and this type of question is going to involve parallel lines, triangles containing parallel lines like we did, corresponding angle or alternate angle. So we are going to solve one question. Okay. Okay, so this is the question. These are the type of question that they will bring in your exams when angles, when uh, questions in an angles, with angles is coming. You see tough questions. Questions like this, if you're able to solve it, then it means you are there, you are learning hard, you are okay with. I mean, you understand angles, not the easy ones. Yes, we started with easy questions. As time goes on, once we are moving forward, then tough questions are coming to crack the brain very well. So this question is a very nice question. Um, so you can think about it once I'm cleaning. You can think about it and work it out. I'm just giving you some short minutes to think about it. Okay, so we are asked to find angle RST. So this type of angle they are telling us to find this side. They are asking us to find this angle. So how do you go about it? Yes, let me show you. You can so search this thing. You have to draw another triangle so that you'll be able to understand very well. Okay. Okay. So okay, I can use this one to explain. You see, this is a parallel line. This is the property that will help you to solve it. You see, these two lines are parallel because of the arrow. So it tells you that ST is parallel to what? PQ. That's the symbol that we use. ST is parallel to PQ. Okay. So since this is parallel to this, um, you see, probably you have to draw another diagram. You have to draw another diagram. So and like something like this, you let me clean it and let me draw another diagram for you to understand, because still you have to draw another diagram for the examiner to know what you are doing. So as far as exams is concerned, I have to teach you how you present your work. Yes, it's good to know how to present your work very well. You don't have to do it anyhow. Nah, you don't have to do it anyhow. Because if you do it anyhow, the examiner will not understand what you mean. So this is S, this is T, and here is 80 degrees. And these two lines are parallel. So after drawing your diagram again, you can represent this is with M, O, N, W. Yes, that is the new diagram. This one will help me to solve the problem. When we are asked to solve this, find for angle RST. So the parallel lines is helping us to solve the problem. Okay, this point is T. But I know that this angle, if I'm considering two parallel lines like this, these two parallel lines, and I know that there's this one, and here is Q, and here is T. This point is T. So the angle, if these are parallel lines, 80 degrees here will be alternate to this, alternate to this. Here too will be 80 degrees, alternate angle. You see, the alternate angle is helping me to solve it. Alternate angle. So that is it. So I can apply alternate angle here to solve that. So I can say angle, this angle 80 degrees. The angle 80 is what? Angle PQR, or you can say it angle PQT. That is this angle. Yes. So angle angle PQT. This is this angle PQT. Or can use it to, you can name it angle PQR, is the same thing. Or you can name it angle TQP. Okay, is equal to this angle. So angle OTQ. Angle is equal to angle OT. Yes, this angle, small angle here. So angle OTQ and is equal to 80 degrees. So therefore, angle OTQ is equal to 80 degrees. What property? Alternate angles are equal. Alternate angles are equal. Okay. So right now, I have this. So here is 80 degrees. If here is 80 degrees, I know that this angle is vertically opposite to this angle. Yes, you see, I'm just applying the property. I'm just applying the property to get the answer. Oh, I didn't bring 70 here. 70 degrees. So here is 70. It's 70 degrees. Okay, let's move on. So I'm also seeing that this angle is the same as that. So angle OTQ is the same as angle RTS or angle STR, this angle. So angle STR, what property is that? Vertically opposite. Vertically opposite angles are equal. Okay, so I can conclude that angle STR is equal to 80 degrees. So over here is 80 degrees. Here is also 80 degrees. Perfect. We are done. Okay, after trying these two properties to get to here, we are asked to find this angle. That is this angle. I've gotten here to be 80, here is 70. I don't know this. So angle in a triangle. That is the properties of triangle. You see, but this one, it involves triangle and parallel lines. So we've learned properties of parallel lines. We've learned properties of triangle. We are adding them together. So if you are able to solve such questions, it means you are there. So angle, this, this angle STR plus angle, this angle SRT or TRS, angle SRT plus the angle we are asked to find this here, angle RST, is equal to 180 degrees angle in a triangle, because this is a triangle. So angle in a triangle sum up to 180. Okay, let's move on. Already we know this is 80 degrees, and we know SRT, which is also 70 degrees, plus we are asked to find this, we don't know RST, it is equal to 180 degrees. Addition, 80 plus 70 will give you 150 degrees, plus angle RST is equal to 180 degrees. So angle RST, we are making angle RST the subject. So this one will cross the equal to sign. It becomes minus 150 degrees. Since it is positive, it's going to be minus when it crosses the equal to sign. So 180 minus 150, which is 30 degrees. We are done. So over here, the angle they are telling us to find is 30 degrees. 30 degrees. Yeah, that is cool question. You see, that is cool question. we are going to, I'm going to write another question, which is also very tough, and we will solve that one too. Okay, so this question, cool question. Um, um, this one too, you see, you have to also, introduce some line, because you see, if this is that and they are telling us to find x, I can extend this line because it's a parallel line. It will move to infinity. So you can extend this and that. So in your new diagram, how to present your work is very important. So in a new diagram, you can draw your diagram. Because when you introduce letters, examiner will not going to see the letters, what you mean, because in the question there was no letters like that. So you have to draw it again and you explain it so that the examiner will see the diagram and understand what you mean. Okay, so I've drawn my new diagram. Okay, so I've drew a new diagram. Okay, so that is the new diagram. Okay. Okay, so we are asked to find x. So if you are finding x, we can use, yes, we can use alternate angle, because this angle alternate to this angle. Yes, alternate angle. Yes, I've seen. So angle QP, we can introduce another angle here, which is W, a point here, which is W. So angle QPW, angle QPW, angle QPW, this is the 90 angle, sorry, 70. Angle angle QPW is equal to, this angle is equal to this angle. So it will be angle PWN. Angle PWN. What property? Alternate angle. Alternate angles are equal. Okay, so this implies that angle PWN is equal to, this side is also equal to 70 degrees. So you can choose to use the implication here. If you like, you can choose not to write it. Just write angle PWN is equal to 70. If you don't know how to use it, don't be using it anyhow. Okay. Right now I've gotten this. I can also use angle, vertically opposite angles. Vertically opposite angles are equal. So this is vertically opposite to this angle. So this angle PWN is equal to this angle. How will we name it? So it will be angle TWS. So angle TWS, or you can name it angle SWT. Opposite angles, vertically opposite angles are equal. Vertically opposite angles equal. Okay, so this implies that angle TWS is equal to 70 degrees. So here is 70 degrees. Here is also 70 degrees. So after getting it, you see, angle in a triangle sum up to 180. So 30 plus 70 plus this angle will give you 180. Okay, so this angle, which is 70, angle TWS plus this angle WT, this one, let me check in the diagram. They represented here to be R. Here to be R. So here to be R. So the angle 30 degrees is WTR. Angle WTR. If you can't name the angle, you are struggling with the angle, you can write the 30 degrees there. Straightforward. But it's good for you to learn. It's compulsory, because as a mathematician, you can't tell me you don't know how to name angle. So you have to learn. Okay. Plus this angle, the angle formed here, which is angle WRT or TRW. Angle WRT. So always the middle number is where the angle is formed. You see, when you check this one, the W is where the angle 70 is formed. When you check the 30, is the T. When you check the R, is where the angle is from, is R, is point R. So that is it. Angle in a triangle, which is 180. We have 180 degrees. Angle in a triangle sum up to 180. Okay, let's move on. So we have 70 degrees plus 30 degrees plus the angle WRT is equal to 180 degrees. So 70 plus 30 is 100. 100 degrees plus angle WRT is equal to 180 degrees. So angle WRT is equal to 180 degrees. This one will causes the equal to sign. You can minus 100 degrees. So 180 minus 100 is 80 degrees. That is, we find for here, and this angle, and it's 80 degrees. So when you are done with it, you can find angle on a straight line. Yes, we are asked to find x, so you find angle on a straight line. So you are going to have straightforward angle. The marker is not good. angle WRT, which is the 80 plus x, straightforward, plus x is equal to 180 degrees. So 80 degrees plus x is equal to 180 degrees. So x is equal to 180 degrees minus 8 degrees, which is equal to 100. That is that. You see, the easy way is that after going through this process, trying to find your 80, you see, this process is very long. Like after reaching here, angle, where is it? Angle TW, yes, angle TWR or RWT, which is 70. This one, after reaching this point, you can choose not to go by this method to get x. You can also use another property that I said, which is easy. Two interior angle is equal to one exterior angle. So going through all this process, you can use that property I told you. So this angle, and this angle is equal to the outside exterior angle, because this one falls here. Okay. Yes. So I will write angle TWS plus this angle WTR is equal to x. What property? Is equal to x. Then over here we have 70 degrees plus what? 30 degrees is equal to x. So 70 plus 30 is 100 degrees is equal to x. Therefore, x is equal to 100 degrees. Easy. So you see, instead of writing all these things using this property, angle on the straight, angle in a triangle, then following angle on a straight line again to get, you see, this process is very long. But this one is very short, but we'll be able to get the same answer. Yes, you see, some properties are very good enough for you to, help you to know to reach your destination very quick. Okay, so that is that. Solving more questions opens your mind. So you are going to solve last question, then we say bye bye to angles. Okay, so let's solve this question very quick. Then we say bye bye to plane geometry one angles. So you are done. Okay, how do you solve this question? This one, you have to draw a new diagram. You have the V here, we have Q. I have my M here. I have O. Yes, R. And we have Y degree here. Yes, S. And let me see. In the question, they are parallel. Okay. But you see, once you be able to solve Y, then you have to introduce another parallel lines at this point, because I told you the parallel lines are lines that do not meet. So this line, I can introduce another parallel line here, which I can name it M. What? Okay, R is here. Okay, P. P. Yes. Okay. So that is that. So once I've introduced a new parallel lines, okay, let's solve it. Here was given to be 60 degrees. Here to 25 degrees. But this is the Y degree. So take note of that. The bigger angle here is what do you call it? The Y degree. So you see parallel lines, this line and this line, these two lines, this alternate to this angle, this small angle here, this small angle here. So this alternate to that. So I can write angle WTR. Angle WTR is equal to, this angle is equal to this angle, which is angle TR, angle TR W, this angle. But this one is the bigger angle, which is Y. So I'm going to have M. What property? Alternate angles are equal. Alternate angles are equal. Okay. So this implies that, this implies that angle TRM is equal to 60 degrees. So right now I've gotten this angle to be 60 degrees. Okay, wow. So this 25 degrees, if I consider these two lines too, they are parallel. So this angle here is alternate to this angle. It's alternate to this angle, small angle here. So I can say this angle 25 is angle RSQ or QST, like this. Angle QSR. That is angle 25. So that is okay, 25. So I can say angle RSQ, or is the same as QSR, is equal to this angle. So angle SRM or MRS. So angle SMR. What property? Alternate angles are equal. Alternate angles are equal. Okay, so this implies that angle SMR is also equal to 25 degrees. So we've gotten 25 degrees. Wow. So this means that 60 degrees plus 25 will give you the bigger angle here. Wow. You're able to get it. Okay, so y degree y this y will be equal to y degree will be equal to angle. This angle y degree is equal to this angle plus this angle, so which is equal to this angle TRM plus angle SMR. So we have 60 degrees plus 25 degrees. So 60 degrees plus 25 degrees, we are going to get 85 degrees. Perfect, we are done. So y degrees is equal to y degree, but we are asked to find the value of y. So therefore, y is equal to 85. Y is not a degree, because if you indicate degree there, when you place it there, it's going to be 85 degree. So the value of x is. Thank you for following. Make sure you subscribe to this channel and follow for more. And make sure you drop more comments under it. Anytime I post video, you make sure you watch it fully. Yes, thank you very much. Bye.